Hello, hello. Just waiting for the screen to react to make sure I'm live. Okay, I think we're live now. So, hey, happy Thursday. It's February 6th. And yeah, I figured we'd do a Facebook Live to cover snowstorms. All right, so we got one right outside the window here. And we have another one on the way for this weekend. So, yeah, it was a good call that they called schools off and everything. And I know a lot of people still have to work and everything. So, hopefully, everybody's staying home and staying safe. But yeah, figured a good time to just chat about snowstorms. And yeah, Groundhog Day, Puxatawny Phil. Yeah, he was right. He was right. Winter's still continuing, definitely this week. And yeah, it definitely looks like the long term as well. We'll take a look at today's storm. We'll take a look at this weekend storm. And then a little bit into the long term into next week as well. But I'm going to try. I'm hopefully getting a little better at Facebook Live, trying to monitor everything going on in the dashboard. There's still a lot of pop-ups that pop up. I'm trying to X out of them. And I know where to look at comments on the screen as well. So feel free to pop in with any questions or comments as we go along. David Anderson, hey, morning from Wilton. All right, you're just right up the road. And we'll kind of dive on into this. And now I'm going to get rid of my ugly face and we'll get into, wait. I want to start with radar. So just to see what's going on right now. This is basically real time. I mean, this is what we call nowcasting. Obviously, forecasting, trying to predict what's coming in the future. But as the storm is imminent or in progress, that's called nowcasting. So we want to take a look at what's going on right now. And then we'll take a look at what's going on way up in the atmosphere, kind of like a bird's eye view, and then drill down from there. So yeah, I'm using WeatherTap. This is a great site. I've been using this for probably well over 20 years. It is a subscription, but I've just used it forever, and it's a great app. But yeah, just kind of zooming out a little bit. Low pressure is working its way through the Great Lakes. Now it's translating to a surface low across Pennsylvania right now. Now this is the warm front extending out to the east here, the cold front draping down through West Virginia. So yeah, the snow has already started. We are expecting that to happen between 7, 9 o'clock, and then working its way into Maine as we head towards lunchtime. So yeah, it's all snow for everybody. We'll just drill down a little bit more, and let's see. I'm just trying to shift this around. Here we go. So very light up here. Getting a few bands to push through. Looking out my window, it's very light snow. It's very small. It depends on the temperature at which the snow develops. If it's really, really cold aloft, sometimes the snowflakes where they are generated are smaller in nature. They could be like conical shaped. They could be plate shaped, as opposed to the really beefy dendrites. Those are like the typical snowflakes that you see that are depicted. Those are called dendrites. So again, it just really depends on the temperature profile aloft and where the snow is generated, and then, of course, the layers that it falls through. Right now, it's falling through very, very cold air at all levels right now. Temperatures right now, actually, let's take a quick look at that. Surface obs. Here we go. I'm just going to bring this over here. Yeah, I mean, we're just, in the teens for most areas, single digits up north. So then in the 20s for southern New England. So yeah, all snow. But the thing is, there's going to be some warm air aloft pushing in, aloft. So what that does is it helps melt snowflakes aloft, and then it falls back into the colder layers towards the surface. So that's why we're probably going to be getting some of that mixing, and I'll cover that here a little bit more. But that's what's going on right now. It's not a very wrapped up system. So let's go further up in the atmosphere to see what's going on. And I'm going to try to check over the comments and everything. So we're going to look at the 500 millibar chart. Again, this is, if you've heard me talk about this before, this is an overall average of the atmosphere. It's kind of a streamlined average view of where the major troughs and ridges are in the atmosphere. You do look at all the other levels, way up at the jet stream, all the way down to the surface, but this is just kind of an overall view. Now, this is right now. This is the GFS model. I go to Tropical Tidbits, this model site. It's pretty good. I go back and forth between a couple of model sites, and you'll see a couple of those coming up. But this is the time period for right now. But just go back in time a little bit. Just going to kind of go in reverse a little bit. So what is the setup? So as you can see, what's this big red area right here over Alaska? That's a major ridge. Okay, it's a long wave ridge, and this is a long wave trough. Long wave means it's a very large feature, a very large synoptic feature. Then within that upper level flow, you get these minor ripples called short wave troughs. So long wave ridge, long wave trough, then embedded within that flow are short wave troughs and short wave ridges. So it's a combination of those. That will come into play. I'll show you why that's a factor. So the ridge over here, now winds around a ridge are clockwise, so it's pushing this cold air down and then into a trough here. So the flow flattens out a little bit here. So the first ingredient for a snowstorm is cold air. And that's what we're getting pushed in from central Canada into the central part of the US. So we're going to go forward in time. Now we get a little bit of a ridge here for right now. That's why we had that warmth here earlier on this week. It didn't make it into us because we have this trough holding its ground. So we're going to go forward in time. And then see this trough starts to move across the eastern US, or across the northern tier and into the Great Lakes. That's a system that is affecting us right now. Now, embedded within this, now this is the difference between the storm for today and the storm for this weekend. Now, what I'm going to do is I'm going to go up into the jet stream here. This is 250 millibars. It's about 30,000 feet. That's the jet stream, okay? So again, go back in time. The jet stream is pretty much right along the northern tier of the U.S. And it's kind of scooting along. Now, for today, we have this very, very small feature right here. That's a trough moving into us right now. That's what's affecting us, okay? The strongest winds of the jet stream are still way back here. So that's why this system is not all that strong. It's not that big or anything like that. But that's what's coming through today. Now, the thing is, there's a lot I'm trying to explain, so hopefully this makes sense. But there are other parts of the jet stream. There's one coming in from the northern tier, but then also this jet stream coming in off of the Pacific. Now, within that is an embedded shortwave trough. Kind of going back to here, you can barely see it. See this feature right here? That's what's scooting across. And coming up, wait. Let me make sure I got this timed out right. Let's go back in time. Right here. Sorry, I had the wrong one. Right here is a very, very small shortwave trough. It's embedded within the long wave flow. That's what's coming across and affecting us. This one is a little bit stronger, but it's not synced up with the one that's coming through. Again, it's very hard to see within this flow, but if you look at, I know I'm jumping around a lot. This is probably going to get a little confusing, all right? Vorticity. This is the spin in the atmosphere. This helps create disturbances. This is our feature right now, right here. That's what's coming through us right now. But see how this other stronger one is back here? They're not synced up. If these two were synced up, this would be a stronger storm, but they're not. They're separated. So that's why this little feature, this is today's storm. The stronger part of it is way back here. So the fact that these are not synced up or coupled means that's why it's not as strong today, okay? So you have to look at a lot of things in the upper levels of the atmosphere. I'm going to jump back up into the jet stream. Way up at 250, okay? So this is what's going through for today. Again, a fairly weak system. That's why we were not really expecting a whole lot of snow with this. But I'm going to jump ahead, and we'll come back to this a little bit later for this weekend storm. But then see the difference for this weekend as we go ahead in time. Whoa, this is this weekend. Whoa, look at that. That's a strong jet stream. Now we're talking a little bit stronger of a storm for this weekend. So you can see the difference. This is today, and then this is this weekend. Okay, we'll come back to that. Okay? All right, let's look at the surface level. This is the GFS. This is the US model. This one goes out a long ways. It's kind of like a good overall model. We compare it with a lot of other models. There's a European, the UK Met, the Canadian, the Japanese model, all sorts of stuff. Then there are ensemble runs and everything. But anyways, we're just going to look at this. So this is what's happening today. Again, remember up at the vorticity chart, you can see this other system up here. This is our system for today. They're not synced up. If these were closer together, they would combine energy and it would be a little bit stronger, but they're not, okay? So that's why we're not expecting a whole lot out of this. Now, it's a very flattened flow from west to east. Remember, I covered this the other day. I posted a chart with meridional flow and zonal flow. This is a fairly flattened flow. As opposed to way up here, it's really wavy, but not here. So when it's flattened like that, there's not a whole lot of amplitude to the pattern. A higher amplitude means stronger storms, but it's flattened, so it's not as strong. That's why it's going to scoot through pretty quick. It's moving from west to east pretty quick. It doesn't have a whole lot of time to get all spun up and stalled out. It just doesn't do that. So that's why it's fairly weak. So that's going to scoot through. And that's why it's going to push out of here for later on this afternoon and evening and clearing out. Now, the other part of that system is going to be coming through for tonight and into Friday. So winds around a low are counterclockwise. So we're going to get that colder northwesterly flow. This is the cold front behind it. This is the colder air rushing in behind it. And that's why we're probably going to have some lingering snow showers into Friday, but mostly for, northern Vermont, New Hampshire, and Maine. That's where the ski resorts are. So it's always good. Even when big storms blow through and you get the snowstorm, the mountains, they still get additional snow after that because of that northwesterly flow. And when winds get pushed up against mountains, it's called a mechanical uplift or orographic flow. So when winds get pushed up I'm sorry, I'm just looking at a comment. So when winds get pushed upwards into the atmosphere against mountains, that creates showers. So that's why you tend to get showers continuing in a northwesterly flow across New England. Jay Peak is notorious for that. The Jay Peak effect, they always get much, much more snow. Just due to that orographic flow, especially after storms depart, you get it in that northwesterly flow. Mountains further, actually, let me zoom down a little bit. To northeast U.S. Here we go. That's why you typically get these lingering snow showers here. Yeah, Jay Peak way up here in Vermont. Oh my goodness, they always get a lot more snow. But then resorts further down, then you tend to get a little bit more of that shadow effect. But still, you get the snow showers, but not as much additional accumulation afterwards. So again, right here. So this snow is going to it's all snow for everybody. But then, like I was covering before with the map, I'll show that to you. We're going to get a little bit of this mixing to come in to southern New England. But by the time it works its way into central and northern New England, the precipitation is going to be shutting down. So that's why I was worried about a little bit of that icing. Now today, I am going to be watching radar very closely. Hi, Shai-Jin. Hey, how you doing? I just want to say hi to you, my buddy. All right. He helped me with my website, so he's a good guy. So yeah, we're going to be getting some of that mixing in. Now, the reason I wanted to follow that for today, now we're going to get that light fluffy snow to start. When we get that transition to come in on the tail end, I try to go out before that hits and try to clear out as much snow as I can before you get that icy crust on top of it. It's just a little bit easier to clear out. So hopefully we can, take advantage of that. So this will work in for basically early to mid-afternoon. So hopefully we can time that out. But then this moves through and then it pretty much winds down. The local timestamp is up here. I'm so used to looking at the Zulu time, which is up here, which is Greenwich Mean Time. You always being in weather, you always go off of Zulu time. That's how maps and everything are run on. So you just mentally know the time locally because we're 5 hours behind. And so that's just one of those things. So sometimes I look at the local, but I'm always used to looking at the Zulu time up here. So again, that's today's storm. Again, this is a GFS model. Some others varied a little bit on, how much freezing precipitate or the mixing that was coming in, where that was going to lie. But this was my overall snow chart for today. Actually, this was the snowfall. Again, very light for northern Maine, but overall the small shovel. Now I'll cover the categories. This is, kind of changed throughout the winter, just trying to figure out what categories I like to go with, what are the amounts, and I'll cover that here. But this, I figured most area would be under the small shovel, and which is generally under half a foot. I basically say like a nuisance snow is basically a coating or trace. Trace of snow is if you get one snowflake to fall on the ground, that's technically a trace as far as observations go in weather. So anything from a trace or coating or a dusting to say maybe a couple of inches. So that's what I consider a nuisance snow. We can handle that. It's just like, whatever. Just sweep it off, no big deal. Small shovel is still under half a foot. Okay, so now we're talking about 2 to 5, maybe 6 inches. That's the ballpark amount that I'm looking at for a small shovel. So that's why most of the area is going to be under that. Now, why did I put the big shovel in here? Okay, there are going to be some heavier bands that set up, but the best chance of that is going to be across southern New England. Okay. Now, with snow ratios, with the cold temperatures, it's going to be fluffy to start. So, if we were to go the whole time with fluffy snow, we could probably maybe get close to 5, 6 inches, that sort of thing. But then the freezing mixing precipitation comes in and tamps it down. So, when all is said and done, we're still below half a foot, but could there be a chance of getting close to maybe half a foot? Possibly. But I couch that because I don't expect that to be a widespread thing. Okay. And then right here, I mentioned a nuisance snow because it, like radar's showing, it's all snow right now. But this mixing is going to be moving in earlier than what we get across central and northern New England. So that's why I kept the snow amounts low here before the mixing comes in. So this map I had was, yeah, it's going to be all snow, but then it turns to rain here, and then we're going to get that mixing to come in as this storm ends. I probably could have pushed this up a little bit further into central New England. But again, by the time it gets up here, the precipitation's winding down. So that was the reasoning behind that. And again, all snow up here. So that was the reasoning between these two maps. And again, it's hard to depict a complex storm in just a map or two. You know, the guys on TV, they have all the fancy graphics and everything. I don't have that. As you can see, I'm working with, with PowerPoint. So it's very, very basic. Again, I was a radio guy. I talked about whether I could get it across over the radio and through a microphone, not through graphics. And my forecasts were in text format. So this is new to me. So that's what's going on right now. I'm just checking comments. Anything going on over here? Okay, if you have any questions, post them. I'm happy to answer them. All right. So that is for today. Anything else about today's storm? So that moves out Friday snow showers, and then, well, I guess we can move ahead into this weekend. So this is Friday right here, northwesterly flow. All right, what's coming along for this weekend? There we go. Now, again, we're a few days out, so do not take these maps literally. Okay, I'm going to go back into the upper parts of the atmosphere to show you what's going on. The jet stream, okay? Like I said before, this one did not sync up with the other jet stream disturbance coming in from the northwest, so that's why it's a bit weaker. However, moving into this is Saturday midday, the jet stream, a lot stronger, but still a very flattened flow. If this was curved like it is way up here, if this whole area was way down here, that'd be a much different story. But it's not. The jet stream is pretty much flat, west to east. Now, there are different quadrants of the jet stream. This is called the jet maxima, the area of strongest winds within the jet stream. Now, if you were to cut this into quarters, draw a line this way, draw a line this way, this is, it splits it up into quadrants. Now, there is a quadrant of this jet max that is more conducive to storminess. It pulls air upwards from the ground to the upper parts of the atmosphere more than other quadrants of the jet maxima. We're getting into some real nuts and bolts, but this is how it works. This left front quadrant is where you get more divergence aloft. When you have divergence aloft, that means air moving up. It's sucking air in from the surface and upwards. When you have air moving upwards, that means more storminess. So this left front quadrant is going over where? Us, the Northeast, New England. So that's a good thing for storminess. But again, it's not going to get too wrapped up. It's going to be in and out, and that's it. But that is why we are expecting more precipitation. It's not going to be a long duration storm. You can have, storms with less precipitation, but if it stalls, then yeah, you're going to get more precipitation. Doesn't mean it's all that stronger. It just stalls. But this one is a stronger storm, but it's going to be fairly quick moving. How does this translate to the surface? I'm going to widen this out a little bit, okay? And we'll just move ahead to this weekend, and there you go. See, again, it's just bam, bam, bam. It's in and out of here within a couple of frames, 2 or 3 frames, and each frame is about 6 hours. So that's why it's going to be a quick mover, but a little bit more precipitation. We're going to look at the QPF, the qualitative precipitation forecast, and then we can kind of look at some numbers that way. But again, since it's fairly flattened from west to east, we're not expecting that northerly push of mixing. So that mixing is expected to stay mostly across southern New England, if anything. So that's why we're expecting mostly snow. Again, this is one model. There are other models. Do not take this verbatim, but it has been fairly consistent from model run to model run. That is what you look at when you're forecasting weather. It's like you can look at a model run, just pop in on one day, and one model run shows a massive storm, and then the next model run, it's gone. That happens all the time, especially way further out in the future. You could go, I'm going to zip ahead, blah, 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 blah. And then you can see storms coming through. Oh my goodness, oh my God, look at that, another storm. Do not take that verbatim, because then the next model run, it may not be there. You look for the consistency within model runs. Is it flip-flopping from left to right, north to south? That's the consistency that you look for from day to day and model run to model run. It's been fairly consistent, and between the models, you can look at the European and see how that's looking. Again, fairly similar, but they'll vary in the very specific track and how much precipitation each has, okay? But yeah, it's looking to be about Saturday night. It's going to be wrapping up about Sunday morning. So it's been fairly consistent, so I think we can definitely lock down that we're going to get a storm coming through, but what about amounts? Okay, let's take a look at that. Actually, I'll come back to this. I was going to mention something weird. Anyway, I mention stuff weird all the time. That's just me. All right. Any other questions? Any popping up? Any questions? Anybody? All right. So again, QPF, qualitative precipitation forecast. Now this is for today's storm. This is the GFS model. This is why we haven't been forecasting a whole lot of snow with this. You're talking about 0.2 to 0.5 inches of liquid precipitation. Now, how does that translate to snow? It's generally, you start with a 10 to 1 ratio. So 0.2 is 2 inches, 0.5 is 5 inches. But then you got to consider, okay, what's the fluff factor? The mixing that comes in with the models, how much is one model run dropping is, and this is how much it could drop. It doesn't mean all of it will. Then it depends on local effects, terrain effects, and then the mechanics within the storm as it plays out. It's not always going to drop exactly this amount. It's just, this is the liquid precipitation within a column of air that could fall if it all falls at once. But sometimes it doesn't, sometimes it does. So that's why I kept it generally under half a foot. But then a fluff factor, you increase the snow ratios, maybe 15 to 1, when it starts off. So perhaps you'd add another inch or two. But then we're going to be working that mixing towards the end. So it's going from fluffier to a little bit less of a snow ratio, and then that mixing tamps it all down. So there are other factors you gotta consider. Now, this is for today's storm. Now, other models showed slightly different numbers, but again, generally under half a foot. But again, for some isolated pockets that could get, maybe up around half a foot. That's why I kept that big shovel in there. Now, looking ahead to this weekend. Let me get to the right time frame here. Is it this one? Okay, there you go. This is for Sunday morning. Looks a little different, doesn't it? Few higher numbers here. Now you're talking about half a foot in if that was a 10 to 1 ratio. Now, again, do not take this verbatim. This is generally saying, okay, now we've looked at the upper levels of the atmosphere. We know that the jet stream and the vorticity, those things are coming into focus. Like, okay, it's going to be a little bit stronger, and then it's going to carry a little bit more precipitation. So that's why amounts for right now is okay. We're looking at more than what we're going to get today. Then you can kind of compare this between other models. You can go back and forth between the European, again, generally about half a foot. In liquid, this is 10-to-1 ratio. So then we got to consider fluff factors. So looks like mostly southern New England would be in the jackpot. Northern New England kind of misses out on this one. Again, with a flattened west to east flow, that's what you typically get. The delineation between snow zones is pretty flat from west to east. You're not going to get a big northerly push with that. So I will fine tune the maps as we go through the next day or two, to reflect some of those snow amounts. But that's generally what we're looking at, and this should be mostly falling Saturday night, winding up Sunday morning. Let's just take another quick look at. Let's just. This is the. I'm going to go to the GFS. Okay, just stay consistent with one model. Okay, so this is in and out of here. Then this is about midday Sunday, and then it's pretty much winding down. So cleanup will be late Sunday morning into afternoon. That's the timeline that we're looking at. Now, okay, so we've covered today's storm. We've covered this weekend storm. Again, if there's any questions, pop them into the chat, and I can answer those. Now, looking ahead. Now, the other day, I mentioned that there's going to be a parade of storms, and I love a parade. Now, I say that because look at this. Bam, 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 bam. Okay, do not take that verbatim, but you can get a sense that we're in a very unsettled pattern of a parade of storms. Now, I love a parade. That's actually a callback to a guy I used to work with, Frank Simon. This goes out to you. This is I Love a Parade. It's like a 1932 Harry Richmond song. I love a parade. The tramping of feet, I love every beat I hear of a drum. And when he was in a good mood, he'd come into the office and he would just blurt out, oh, I love a parade. So, again, a throwback to my buddy Frank Simon, who I worked with in the Air Force. He was actually the civilian working in the office I was at, but he always used to sing that. And but when I saw the pattern of a parade of storms, that's why I wanted to mention that. Anyways, so that's kind of what we're looking at. You know, if you go up into the 500 millibar chart, this troughiness across the western central part of the U.S. continues. So you can just sort of see that storm track from west to east, still pretty consistent in the long term. It really is. So, Punxsutawney Phil, yeah, you're right, dude. You know, we're going to get a little bit of a stormy pattern for at least, probably the next couple of weeks or so. Wow, I covered quite a bit. It's been about half an hour, so I think I covered everything I wanted to today. If you wanted to, you can check out these model pages. Tropical Tidbits is a good one. The HRRR, the High Resolution Rapid Refresh. Oh my God, I can't even say it right. High Resolution Rapid Refresh Model. This one is a little bit more specific. This drills down into hourly increments of a storm. Other models have different resolutions. They widen in scope and time frames. Some go up to 3 hours, then 6 hours, and some 12 hours. But it just depends on the model. But the HRRR, the High Resolution Rapid Refresh Model, is more of a depiction of the radar, the expected radar within hourly increments. So again, you can see this is that freezing, that mixing scenario comes into play, and then the local timestamp is over here. The Zulu time is over here. So then by about 1 p.m., that mixing is coming across central New England, right along the Mass New Hampshire border, and then as the precipitation fizzles out, it's moving upwards a little bit to the northern areas, and then fizzling out. So that's basically what you can look at as the storm happens. Again, this is a little bit more higher resolution. But that's about it. I don't think I have anything else for you. I think I'll call it good. Now I'm just going to go through radar. Let's just take a quick look at radar, see what's going on. This auto refreshes, so this should be current. Yeah, 9:30, the timestamp down here. So getting a few heavier pockets moving in across the Berkshires and into southwest New Hampshire and southern Vermont. And we'll watch that mixing line as it moves northward. So I'll post updates as we go through this about lunchtime, early afternoon, and try to plan it out. So maybe we can kind of get out there and shovel the snow before that mixing comes in and tamps things down. And that is about it. So I'll keep posting maps for this weekend for sure. And again, thanks for checking in with us this morning, Shai-Jin and David. And any other questions out there? I think that's about it. Okay. Well, I'm going to call it good. If you have any questions, post. This will be posted on the timeline as a video, and feel free to comment there, and I'll answer them as quick as I can. All right. Well, enjoy the storm, and we'll check back for this weekend storm. All right. Take care, everyone. See ya.